Hey guys, how's it going? So this is going to be my second video on data analysis and statistics used in medical physics. And we're going to start where we left off, starting with problem 8, getting more so into different statistics. Okay, problem 8, part A. What does a significance level alpha mean? The significance level, or alpha, is the probability of rejecting the null hypothesis when it is true. So give me an example using alpha for left-tailed test, two-tailed test, and right-tailed test. So the standard alpha typically used within research experiments is 0.05 or 5%. Here's an example of a left-tailed test at 5%. Notice that for a two-tailed test, you're going to be splitting the alpha into 2.5 at the top and 2.5 at the lower region. And here's a right-tailed test, 5% along the right-hand side. Part C, so what is a confidence interval? Essentially, the confidence interval is 1 minus your alpha. What it's saying is that the confidence interval is is in which the null hypothesis will exist when it is true. So otherwise, so it's the opposite of the alpha in this case. So if you're able to calculate a value, this is going to be your significance level, your alpha selected. That's going to be within this 5%. Essentially what you're doing is you're rejecting the null hypothesis. For D, calculate the confidence interval for each case in B. So pretty simple. All you're doing is taking 1 minus alpha. Okay, so now we're going to start getting into the different statistical tests, being Z, T, and F. So let's start off with the Ztest. Now this is it's going to be a simple example that we're going to go through, but I think you'll get the point from this example. So starting with A, what is a Z-test? It's essentially a test. It's a like a hypothesis test used to figure out if the null is correct or can be rejected. B, when can you use it? So essentially, to use a Z-test, your sample size has to be 30 or greater. Your data points should be independent from each other. And in this case, you have the standard deviation of the population. What is the basic formula for Z-test? So in this case, the formula can look a little bit complex, when you're just looking at the variables. So I decided to also include the numbers in the example so you can compare it. Let me just read through the example that we're going to work through. So a principal claims the students are above average IQ. A random sample of 30 students' IQ scores have a mean score of 112. The mean population IQ is 100 with a standard deviation of 15. And just to be clear, the IQ scores are normally distributed. Okay, so in this case, this is the mean sample. This is going to be 112. And you're going to subtract the mean population. So the mean population IQ is 100. And we're going to divide by the standard deviation of the population. Notice that we're saying of the population, because that's going to be a difference that we're going to see in the t-test. So standard deviation of 15 of the mean population. We're going to divide it by the square root of the number of sample. In this case, it was 30, random sample of 30 students. And we calculate a value of 4.56. So at part D, let's apply the Z-test to validate the hypothesis, kind of what we're working through. So the null hypothesis in this case is going to be that the mean IQ is 100. The alternative hypothesis is that the IQ is greater than 100. and we're going to pick a significance level of, or alpha, of 0.05. In this case, as I mentioned before, this is typically the significance chosen is 0.05. Now, we calculated our z value, but what we're going to do is we're going to calculate a like a critical z value to see if we can reject the null. So essentially, what we're using is our alpha, and this is it's a z table. There's many different z tables and z calculators that can be used. In this case, we're using a z table, and we found it to be the critical z value is 1.645 in this case. That's going to be the critical z value if we can reject the null. So in our case, 4.56, our calculated z is greater than 1.645. So in our case, the 4.56 is going to be within this region. We can go ahead and reject the null. So the conclusion is that students do have a higher IQ than average. Principal's claims are correct. Okay, so here's another statistical test, the Ttest. Very similar to the Ztest, so be careful here and I'll make a distinction. So what is the Ttest? Essentially, it's the same idea as the Ztest in that it's a statistical test used to determine if the an experimental results are valid or could be repeatable. It's your null hypothesis and your alternative hypothesis. But for part B, when should you use it? Your sample size is less than 30. Notice that with the z-test, we're going with sample size greater than 30. Data points should be independent from each other. That's the same thing as in the z-test. But so for a t-test, you do not have the population standard deviation. So I and 3 are going to be the difference between t-test and z-test. And in these cases, in this case, for I and 3, you're going to be using a t-test. What's the formula for t-test? I'll go ahead and show it with the values so that it's easier to distinguish. Let's read the example. The average test score for an entire school is 75. The standard deviation of a random sample, so this is not the standard deviation of a population sample, of 9 students is 10. So what is the probability the average test score for the sample is above 80? Notice in this question, we're not calculating, we are going to be calculating a t-test, but it's a different example. We're going to be using that t-test value to calculate a probability, which is also known as a p-value. So let's go through the variables in the t-test. This is going to be the mean sample. In our case, it is 80 minus the mean population, which is 75, divided by the standard deviation of the sample. In our case, it's 10. And then we take the divided by the square root of the number of samples, which is 9 students. We get our value for t-test of 1.5. So to calculate the p-value, we need to calculate the degrees of freedom, which is the sample minus 1. It's 8. Okay, so from here, to go from a t-test value to a p-value, you can either use tables, or you can go online and search for a p-value calculator from Ttest. In my case, I just used a calculator, calculated 0.86 or 8.6%. So I noticed that with statistics, there's a lot of tables to be used. You can look for critical values for any of these statistics tests. You're going to be using a table. It often requires significance level or alpha and the degrees of freedom. To go from any of these statistical tests to probability, you're also going to be using a table again, or it could be online calculators in this case. So a lot of different tables being used. Okay, problem 11. This is This is referring to an F-test, which is different, significantly different than a Z-test and a T-test. Okay, so what is a F-test? It's a statistical quantity used to compare two sample variances. For part B, how do you calculate a variance? A variance is just your standard deviation squared, right? So for C, what exactly does variance tell us? Variance is an informal way to measure how far a set of random numbers are spread out from their mean. Part D, what's the formula for F-test? It's your variance of your first sample divided by the variance of the second sample. Notice that because you're dividing the variances, there are no units, right? They're going to cancel out. Important to distinguish. Let's work through an example in E. Let's use a two-tailed F-test to verify the null hypothesis. And for both samples, we're given a variance and a sample size. So plugging in the variance for sample 1 and sample 2, I get a value of 1.66. In this case, let's many instances when you're using F-test, your null hypothesis is typically that the variance of the first sample is equal to the variance of the second sample. And your alternative hypothesis is that they're not equal. Okay, so we got our value of 1.66. In this case, we want to calculate a critical F value, and we're going to need the degrees of freedom and a significance level. In our case, we'll go with the standard 0.05. Degrees of freedom, 41 minus 1 is 40, and then 21 minus 1 is 20. And essentially what I'm doing again, once again, is I go to an F value table. I find a value of 2.07. 1.66, our value calculated, is less than 2.07. In our case, we are going to reject the null. Alright, problem 12. If p-value wasn't clear, problem 12, we'll be talking a little bit more about p-value. So what is a p-value? Essentially, that's probability of obtaining your sample data if the null hypothesis were true. So if a p-value is 0.85, can we reject the null? No. That indicates you have little reason to doubt the null hypothesis. Part C. In a research setting, so we went over this quite a bit, but just to drive it home, in a research setting, what p-value suggests strong evidence against the null hypothesis? This is typically what value they use. It's at 0.05%. Part D, just to drive this home. So how do you calculate a p-value from Ztest, Ttest, or F-test? You're going to be using, first you're going to calculate the p-value, you got to find the degrees of freedom. You're going to select a significance level, or alpha. Then you're going to typically use a table to find the p-value, or some sort of online calculator. Part E, let's say your alpha is 0.03, so different than the norm, and you calculated a p-value from a z-test that equals 0.02. Can we reject the null? Yes. There's enough evidence to reject the null in this case. Okay, so problems 13 and 14, we're going to be switching it up and talking about chi-square tests, because these seem to come up quite a bit. Okay, so this is something I used to confuse very often, and that is that there's three different uses for chi-square. So I decided to make that the main idea of this question, because I used to confuse it quite a bit. So there are three different uses for chi-square tests. Name them, define each chi-square use. Okay, this is probably the most popular one. It's the chi-square test for testing goodness of fit. We're going to do an example calculation in the next problem. So this is used to decide whether there is any difference between the observed experimental value and the expected or theoretical value. It's hypothesis testing, once again. The second use, chi-square test for independence of two attributes. So suppose, as an example, suppose we have n observations are considered and classified according to two characteristics, like say A and B. We may be interested to test whether the two characteristics are independent. The third use for chi-square test is for single variance. This is used to test a hypothesis on a specific value of the population variance. But since chi-square test for testing goodness of fit is the most popular, I'll run through an example. So problem 14. What's the formula for chi-square and define all parameters? Chi-square is equal to the sum of the observed value minus the expected value. You're going to square it, divided by the expected value. And this is the sum of, so you're going to add them all up. I designates the position in the data table. So let's run through an example. So I want to know how many Tim Hortons coffees are sold on Monday, Tuesday, and Wednesday. So essentially, I ask my friend who works there how many, and he tells me on Monday there's 300, Tuesday there's 400, and Wednesday there's 350. But for those days, so let's say he typically tells me these values. And for those days, I go ahead and sit inside Tim Hortons and observe how many there actually are. And I count on Monday, Tim Hortons sells 333, Tuesday 407, and Wednesday 375. So let's determine if my friend gave me an appropriate answer using chi-square. It's goodness of fit. So let's run through. Okay, so in this case, let's designate my my null hypothesis and my alternative. So typically, the most common null hypothesis and alternative are going to be for chi-square goodness of fit is that for example, my friend told me the correct amount. It is the correct amount. The other one is that my friend did not tell me the correct amount. And let's go ahead and input those values into the chi-square formula. So going through the first one, for Monday, observed 333, put that in for observed, minus expected coffee, 300, I square it, take the difference, divided by 300, I get 3.63. I go ahead and do that with Tuesday's values and Wednesday's values. I calculate a total chi-square of 5.54. Now, I have to come up with a critical, well, I have to obviously come up with my significance level. I'm going with the standard 0.05. And I have to calculate the degrees of freedom. In my case, there's 3. 1, 2, 3. 3 minus 1 is 2. So now I have to come up with a critical value for chi-square. And I'm going to go to a chi-square table. Go figure. And I find the value of 5.991. So in our case, our chi-square is going to be less than 5.991. So we're going to go ahead and validate the null hypothesis. So in our case, my friend did tell me the correct value with respect to the selected significance level. Okay, so that's it. That's 2 lectures and 14 problems on data analysis and basic statistics with respect to medical physics. And you know, I think they're excellent examples. It goes over many concepts, many of the important concepts. It is a great refresher. By all means, though, it does not cover. It's not all extensive, all inclusive with respect to statistics or data analysis. But the idea behind the lecture is to give you enough knowledge that you know, whatever statistics you want to apply for your research project, you can you have enough knowledge that you can, if it is a more advanced statistic, you'll understand what is occurring, but you will probably have to research more about that particular statistic. You know, look at the assumptions and things like that. So with that, I'd like to thank you for viewing, and that's all.